Number 45. We have f of x equals negative absolute value x plus 3 plus 4. Okay, so I'm going to call that y equals f of x. Alright, so I've got y. And then I'm going to subtract 4 from both sides, so you've got y minus 4 equals negative absolute value, and I'm going to write that as x minus a negative 3. Alright. So divide both sides by negative 1 to get rid of that negative in front there. Y minus 4 over negative 1 equals absolute value of x minus negative 3. Alright. So what this is doing is you're taking the graph of the original function, which is y equals absolute value of x, and this is causing a reflection across the x-axis or in the same direction as the y-axis. Alright, so it's going like this. Alright, and that's causing a shift up 4 units, and that is causing a shift to the left by 3 units. So you take a representative point, for example, you could take negative 1, 1, for example, which is on y equals absolute value of x, and first apply the reflection, multiply the y coordinate by negative 1, so that becomes negative 1, negative 1. And then you can apply the shifts, alright, in either order. Let's do this one first. This is a left shift, so you add negative 3 to the x coordinate, alright, it's next to the x, so add it to the x coordinate. Negative 3 added to negative 1 is negative 4. Negative 1. And then this, add 4 to the y coordinate. Alright. So you add 4 to that. 4 minus 1 is 3. So you get negative 4, 3. So negative 4, 3 will appear on this graph. Okay. And then you can do the same thing. I would do transform 0, 0. That's on y equals absolute value of x, and that's the vertex of that v there. And then do one other point. Plot those 3 points. Plot this one and then the other 2, and connect the dots. And you should get this graph here. Number 47. We've got f of x equals 3 times the absolute value of x minus 2 plus 3. So I'm going to let y equal f of x. So I've got y equals so on and so forth. Subtract 3 from both sides. So you got y minus 3 equals 3 times the absolute value of x minus 2. And then divide both sides by 3, so you got y minus 3 all over 3 equals absolute value of x minus 2. Alright. So this is a stretching, vertical stretching by a factor of 3, right there. And that's a vertical shift up 3 units, and this is a horizontal shift to the right 2 units. So you take a typical point, how about negative 1, 1, that's on the original y equals absolute value of x graph. Again, you do the stretching, shrinking, reflecting first, So you multiply the y coordinate by 3. So you get -1, and then 1 times 3 is 3. Alright, now you can do the shifting. You add 3 to the y coordinate, so you get -1, 6. And then you add 2 to the x coordinate here, so you get 2 minus 1 is 1, so that's 1, 6. Alright, so 1, 6 is on the transformed graph, and you can do 2 more points. I would do 0, 0, of course, transform it similar to this fashion, and then 1 more point. Plot those 3 new points and then connect the dots, and you should get this result. Number 49, we've got f of x equals absolute value of 3x plus 9 plus 2. So again, let y equal f of x. Okay, see, and then subtract 2 from both sides. So you got y minus 2 equals. Now the expression in here isn't in the format that we wish to see what's going on with the shifting and the transforming. It needs to be in the format x minus something. If there's any reflecting, stretching, or shrinking going on horizontally, it needs to be a fraction with x minus something in the numerator and another number below in the denominator. Alright, so this is not in that format. So what we have to do is factor a 3 common factor out of there, out of these two terms. And if there is no common factor of 3 that you can see here, you can always force that. Alright, just whatever this number is, multiply it by 3/3, which equals 1. So there's your common factor of 3, and whatever you have left you leave there, alright, after you do the factoring. So factor a 3 out. That leaves you with x plus 3. Alright, so y minus 2 equals, now this is 3 times the quantity x plus 3. I'm going to write that as a 1/3 divisor. So you've got x plus 3 divided by 1/3, which you can see if you invert this and multiply, you get the same thing back again, right? That's equivalent to this, alright? And finally, I'm going to change that to x minus -3. So you got y minus 2 equals x minus a -3 divided by 1/3, like that. Alright? Okay. So let's take a point on the original y equals absolute value of x graph. Right? I'm going to take 3, 3 and transform it. So again, you apply this. This is a vertical shrink, not a vertical, but a horizontal shrink by 1/3. Okay? It's under the x, so think horizontal. And then you've got a shift to the left 3 units, and over here you've got a shift up 2 units. Alright? So to get that, you take this point that's on the original y equals absolute value of x graph, multiply the x coordinate by 1/3. So 1/3 of 3 is 1. So you get 1, 3. Now, you can do either one of these next. I'll do this one next. You add a -3 or subtract 3 from the x coordinate. So 1 minus 3. Alright, that's -2. 3. And then finally you add 2 to the y coordinate, so you get negative 2, 5. Alright, so that's what happens to the point 3, 3 after you've done the transforming. You get negative 2, 5. And then you can pick two other points. Pick 0, 0, of course. Do that one in a similar way. And also pick one more point and then connect those dots, and you should get this result. $51. So we've got f of x equals the negative of absolute value x plus 4 minus 3. So let y equal f of x and then subtract negative 3 from both sides, so you get y minus a negative 3 is equal to negative absolute value. I'm going to change that to x minus negative 4. Divide both sides by negative 1, so you get y minus negative 3 all over negative 1 equals absolute value of x minus negative 4. Alright, so this causes a reflection across the x-axis going in the direction of the y-axis, and that causes a shift down 3 units, and that causes a shift to the left 4 units. Alright, so if you take a typical point like 1, 1 on the original y equals absolute value of x, multiply the y coordinate by negative 1, you get 1, negative 1. Add negative 3 to the y coordinate, you get 1, negative 4. Add negative 4 to the x coordinate, you get 1 minus 4 is negative 3, negative 4. Alright, so we have the point negative 3, negative 4 on the transformed graph, and you can plot two other points in the same way, transform them the same way, and you should get this result. Number 53. Use a graphing utility to graph f of x equals 10 times the absolute value of x minus 2 on the viewing window 0 to 4. Identify the corresponding range. Show the graph. So if we let y equal f of x, y equals 10 times the absolute value of x minus 2. Divide both sides by 10, so you get y over 10 equals absolute value of x minus 2. Alright, so this is y equals absolute value of x, but stretched vertically by a factor of 10, that's what that does, and shifted to the right 2 units, that's what that does there. And the range is going to be from 0 to 20. Okay, so to see this, you've got the point, for example, 2, 2 on the original graph, y equals absolute value of x. Multiply the y coordinate by 10, so you get 220. And then shift it to the right, so that means add 2 to the x coordinate, so you get 420. So this is the point that's on the extreme right side of the viewing window, which goes from 0 to 4. So you got 420, that's on the right side here of that viewing window, and the Y value there is 20. So that's your range from 0 to 20. Alright, so graphing this, you will get this graph. Number 55. Graph using a graphing utility. Specify the viewing window. So we've got f of x equals negative 0.1 absolute value 0.1 times the quantity 0.2 minus x plus 0.3. Alright, so we're going to let y equal that, and we're going to get this into our proper format. So we've got y minus 0.3 over negative 0.1 equals x minus absolute value of x minus 0.2 all over negative 10. Alright, so in here, first of all, I factored a negative 1 out of these two terms. Put it in front of the 0.1, that becomes negative 0.1 in front, and this becomes x minus 0.2. And this is negative 1/10, which can be written like this. Alright, put the 10 in the, rather the negative 10 in the denominator. And the rest of it's pretty easy to figure out. Alright, so what this is, well, let me number what's going on here. We've got a reflection across the x-axis in the same direction as the y-axis. That's from the negative. Also a shrinking, a vertical shrink or compression, because that's 1/10. So let's call that number 1, because I'm going to apply these to some points to find out what our viewing window is going to be. And then over here you've got a reflection across the x-axis, that's from this negative, the y-axis rather, across the y-axis in the same direction as the x-axis, a reflection from that negative, and also a stretching from the 10. Okay, so I'm going to call that number 2, step 2. Put that in a circle. And then let's go over here. This is a shift up 0.3 units. Alright, so I'm going to call that step 3. And we've got 0.2 shift to the right over here. So that's going to be step 4. Alright. Okay, so reflection, I have a vertical a reflection across the x-axis and also a shrinking, a reflection across the y-axis and a stretch, a shift up and a shift to the right. So let's see what happens to different points on y equals absolute value of x, which would be the original graph. So for example, the point 0, 0, apply step 1. Alright, So you multiply the y-coordinate by negative 0.1 and you still get 0, 0. Now let's apply step 2. So you're going to multiply the x-coordinate by negative 10 right here, but that's still 0. So we still have 0, 0. And then step 3. You're going to add 0.3 to the y-coordinate right there. Alright, so you're going to get 0, 0.3. Finally, we have step 4. And what we're going to do is add 0.2 to the x-coordinate right there. So you get 0.2, 0.3. Alright. Now let's take 1, 1. And I'm going to apply each of these in the same order, so I'm not going to rewrite these step numbers. So we get 1, negative 0.1. And then we get negative 10, negative 0.1. And then we get negative 10, 0.2. And then we get negative 9.8, 0.2. Okay, how about negative 1, 1? So we're going to get negative 1, negative 0.1. And 10, negative 0.1. And 10, 0.2. And 10.2, 0.2. One more point. Let's do 10, 10. So we're going to get 10, negative 1. And negative 100, negative 1. And negative 100, negative 0.7. And negative 99.8. Negative 0.7. Alright. So, in view of these transformations, we should probably make this the viewing window. Alright. So we can go from negative 100 to 100 on the x-axis. And negative 1 to 1 on the y-axis. Alright, so that the negative 100 to 100 on the x would cover all of these x values here, and negative 1 to 1 would cover all these y values. Alright, so if you set that as your viewing window and graph it, I did that on my computer. Here's the result. Number 57. For the following exercises, solve the inequality. So let's see, we've got absolute value of negative 2x minus 2/3 times the quantity x plus 1 plus 3 on the outside is greater than negative 1. Alright, so normally you would just distribute that through and then add like terms and so forth and so on, okay, but we could do a little creative common factoring here. We can factor a negative 2/3 out of these two terms, right? If you think of this negative 2x as, well, here you go. So you're going to multiply, you're going to factor a negative 2/3 like this, and then make that a 3x. Alright, so when you multiply that back through, alright, you're going to get just negative 2x, or think of that as negative 2 times 3/3 x, and then factor out 2/3, right, negative 2/3, negative 2 times 3/3 x, okay. So that gets this one out as well, so we've got plus x plus 1 in parentheses. Alright, like that. If you want to check, multiply that back through and you will get this back again. Alright, so, and then add, or rather subtract 3 from both sides, so that's greater than negative 4. Alright, so now I've got something times something, this quantity times this quantity inside the absolute value, so I can separate those. And that's absolute value of negative 2/3 times the absolute value of, and since we're adding here, we don't really have to worry about the parentheses, 3x plus x plus 1 is greater than negative 4. Alright? Alright, and absolute value of negative 2/3 is 2/3. And then here we've got 4x plus 1. It's greater than negative 4. And so you can multiply both sides by the reciprocal of 2/3, which is 3/2. And so you're going to get absolute value of 4x plus 1 is greater than negative 6. Alright, so that's our basic inequality that we can work with. Alright, so you could do this the standard way, separate it into two different problems to solve and then take the union of the two answers, but if you notice this, would you say this is always true? An absolute value, no matter what it is, will be greater than negative 6. Would you say that's true or false? Well, of course it's true, right? Absolute value is never going to be less than or equal to negative 6, is it? It'll always be greater than negative 6. So no matter what you put in here for x, that will always be true. Alright, so in other words, no matter what you put in there means all real numbers will work as a solution for this. Alright, so negative infinity to infinity is the solution. All real numbers. Alright, so now if you want to solve them separately, you could do that and you would still get a consistent answer, right? I'll skip the details, but I'll give you the solutions to each separate answer. First, you set 4x plus 1 is less than positive 6, or 4x plus 1 is greater than negative 6, and you solve those separately. And so you get the respective results: negative infinity, 5/4, and you're going to take the union of that with negative 7/4 to infinity. Alright. So as you can see, when you take the union of these two, you get everything on the real number line. Okay? And so you're still going to get that answer. Alright. But if you do it logically, just think it through, you can skip those little details on this problem at least. Alright? And get your answer right away. Number 59. If possible, find all values of a such that there are no y-intercepts for f of x equals two times the absolute value of x plus 1, and then plus a. Alright, so if you say no y-intercepts, well, what you're saying is that f of 0 doesn't exist. F of 0 does not exist. Why? If x equals 0, well, that's where you're going to have your y-intercept, right? That's where the graph touches the y-axis, and that's when x equals 0. So you're saying then that f of 0 doesn't exist. But if you look at this graph, y equals 2 absolute value of x plus 1 plus a, all right? It's the graph of y equals absolute value of x, which is stretched vertically by a factor of 2. Let me write it the way I usually like to write this. It's going to be y minus a over 2 equals absolute value of x minus negative 1. So it's going to be a vertical stretch by a factor of 2, and this is going to be a shift either up or down depending on whether a is positive or negative. All right? And this is a shift to the left. Okay? This has a y-intercept. If you let x equal 0, f of 0 will equal 2 times the absolute value of 0 plus 1 plus a. And that's equal to 2 times the absolute value of 1 plus a, which is just 2 plus a, all right, or a plus 2. So you have the point 0, a plus 2. And that will always exist since a is a real number. That always exists. Okay, there's nothing wrong with that. So that's your y-intercept. Okay. So if you think about it, this will cause a stretching of y equals absolute value of x vertically. That's not going to affect the y-intercept. Okay. If you shift it up or down after you stretch it, no matter how far up you shift or how far down you shift, it's still going to touch the y-axis, right? Somewhere. And if you shift it 1 unit to the left, that's not going to affect the y-intercept either. So you can think of it geometrically. All right, go through all of these transformations and think about what the picture is going to look like in your head, and you're going to see that the y-intercept is still going to exist. It'll change depending on the transformation you do, but it'll still be there. There'll still be a y-intercept. Alright, and this, of course, shows you definitely that this will always exist. Since a is a real number, a plus 2 is also a real number, and this point will exist. Okay? So it's not possible to find a such that there is no y-intercept. Okay? Alright, number 61. Folks, we're almost finished. Alright. So we've got the true proportion P of people who give a favorable rating to Congress is 8% with a margin of error of 1.5%. Describe this statement using an absolute value equation. So if you think of P as a point on the number line, the distance of P from 8% is within 1.5%, either left or right. Okay, so you would set up this absolute value inequality. Absolute value of P minus 0.08, which is the same as 8%, is less than or equal to 0.015, which is 1.5%. Without absolute values, you would write it like this. Okay. So the distance between P and 8% has to be within 1.5% or less. All right. There you go. All right, guys, last one, number 63. Let's go through this. It's a lot like number 61. So a machinist must produce a bearing that is within 1/100th or 0.01 inches of the correct diameter of 5.0 inches. Using X as the diameter of the bearing, write this statement using absolute value notation. So if X is the bearing's actual diameter, it has to be, the distance between that diameter and 5 inches has to be less than or equal to 0.01. Okay, either on either side. It could be a little bit bigger or a little bit smaller than 5. Alright, so that's why you would use absolute value on this. Absolute value of X minus 5.0 has to be less than or equal to 0.01. Alright, so if you look on a number line, and this is, let's say, 5.0, and let's say this is, well, I'll just do this, 0.01 on either side of 5.0. Whatever these 2 points are. Alright, so X has to be somewhere in there. The actual diameter of the bearing has to be either a little bit smaller, but no more than 0.01, or a little bit larger than 5.0, but no more than 0.01. So this diagram is expressed in this absolute value inequality right there. Alright, guys, it's done. We've done another section, 1.6. We only have one more section left to go, and we'll be done with chapter 1. So, good job, people. Pat your backs, pat yourself on the back, and take life easy for a while. And I will see you next time. All right.